This is chapter 3, problem 98. At t equals 0 seconds, a batter hits a ball with initial speed of 28 meters per second at a 55 degrees angle to the horizontal. An outfielder is 85 meters from the batter at t equals 0 seconds, and as seen from the home plate, the line of sight to the outfielder makes a horizontal angle of 22 degrees with the plane in which the ball moves. What speed and direction must the fielder take to catch the ball at the same height from which it was struck? Give the angle with respect to the outfielder's line of sight to the home plate. Here I have a visual representation of what's going on. The triangle is within the plane of the page. The flight path, if you're looking down on this leg of the triangle, you would see the flight path from a top view. This is where the ball is going to be catched. This is the home plate. Here we have the position of the outfielder. So this triangle is not drawn to replicate the problem or to represent the problem because we don't know the range, which we don't know the leg of this triangle, and we don't know this leg of the triangle, which is the distance the outfielder must run to catch the ball. While doing this problem, we might decrease this angle or increase this angle. Let's get into the problem. Since the ball is being caught at the same height from which it was hit, we're going to use the range formula. I'm not going to derive it in this problem. You can look in chapter 3 videos and look at the problem for a long jumper, which we derived the range formula. So we're going to use the range formula in this problem to solve for the range. So this is looking at the flight path of the ball, and from that we can get the range, which is going to equal this leg of the triangle. So let's use the range formula to solve for R. So range equals, we know that the initial speed was 28 meters per second, and that's squared. We know that 55 degrees is the angle at which the ball was hit. So 2 times 55, you can just put the degrees if you want, all divided by 9.80 meters per second square, and that's seconds square. The range is going to equal to 75.175 meters. That's the range. So now we have one leg of the triangle. So we need to solve for x. So we have the range, which is 75.175 meters. So now let's solve for x. The leg x is the distance the outfielder must travel to catch the ball, right? So to find the length or the distance of that leg, we can use laws or law of cosines. X is the length we're going to solve for, so x squared equals, finding x, we square that. Let's determine the legs of the triangle. We're going to call this leg A, or let's call this one B. Let's call this B, and let's call this A. X is now equal to, so when we take the square root, we'll have plus or minus, but we just need the positive for this one. So that's going to equal to 32.048 meters. So x is now equal to 32.048 meters. So we would like to find the angle theta at which the outfielder should run to catch the ball. So angle theta at which the outfielder should run is found by the law of sine. Well, before we find the angle theta, let's use this smaller triangle to approximate or to know how large or how small that angle should be. We have the range. So if we use sine theta, that's going to equal to opposite over the hypotenuse. Now r is going to equal to x over sine theta, which will equal to 32.048 meters divided by sine theta, which is 22. That is equal to, so r is equal to 85.55 meters. So if theta is 90 degrees, the range or the hypotenuse of the triangle is going to equal to 85.55 meters. But we know that range is equal to 75.175 meters. So we know that the angle, we know that theta has to be less than 90. And if theta is less than 90, we know that the angle must be acute. So let's solve for the angle, law of sine. So we're going to name, let's call this angle A. This is angle A, and theta is B. Now sine A over A is equal to sine B over B. Sine 22 degrees divided by 32.048 is equal to sine theta divided by 75.175 meters. So let's change the variables that identifies these legs. So let's make the opposite leg. So let's make the opposite leg from angle A equal to A. Let's make the opposite leg from angle B equals B. Solving for theta. So theta is going to equal 61.49 degrees or 118.51 degrees. From this approximation, we know that in order for the range to be 75, we know that the angle cannot be 90 or greater than 90. So thus, the angle has to be an acute angle. An acute angle is less than 90 degrees. So theta is equal to 61.49 degrees. We were asked what speed and direction must the outfielder take to catch the ball at the same height from which it was struck. So we found the angle at which he's going to run. Now we need to find the speed. How do we find the speed? In order for him to catch the ball the same height at which it was struck, we assume that the time of flight is going to be the time that he's going to take to catch the ball. So the time of flight of the ball is found by the horizontal motion of the ball at constant velocity. Horizontal motion. So the range is equal to the initial velocity in the x component of the initial velocity times time, and that is going to be, we solve for t. So now time is equal to, okay, so that's 4.681 seconds. So if we have the time, we can solve for the velocity, or the average velocity. The average velocity is going to equal to the change in distance over time. So the change in distance of the outfielder is going to be final distance minus initial distance, which is just basically saying distance over time, and that is equal to 32.048 divided by 4.681 seconds meter. This is going to equal 6.8 meters per second. So his average velocity is equal to 6.8 meters per second at an angle of 61 degrees. So this is the speed of which the outfielder is going to run, and the direction is the angle. So as you can see, basically this triangle was not drawn to scale because we did not know the range, which we did not know this leg of the triangle, we did not know this leg of the triangle, and we did not know the angle at which the outfielder has to run to catch the ball. So basically what's going on is the average velocity of the outfielder must be 6.8 meters per second, and he has to run at an angle of 61 degrees relative to the line of sight, which is, this is the line of sight, to catch the ball at the same height at which it was struck. That's it.